Hello students, welcome. Previously, lesson 19 from 4 topic 4, we were dealing with the qualitative treatment of electrolysis, and we have done Faraday's first law of electrolysis calculations or problems, and we have done the first problem or the first aim, which was determining the quantity of electricity passed. So today, lesson 20, we want to proceed to the second aim in the calculations of Faraday's first law of electrolysis, which is determining the mass of substance produced. So learn us, we can use one formula, and that formula is here. Mass deposited is equal to Q multiplied by RAM and divided by N times F. So if you want to get Q is given by IT, where I is current, which is measured in amperes, and T is time, which must be in seconds. So we're saying where Q is the quantity of electricity passed, M, which is here, is mass in gram deposited. That's what we are calculating in this lesson. Then we're having N, that's the number of Faradays. Then we're having F, that's the Faraday, which is 96,500 coulombs. Then RAM is the relative atomic mass of the elements. Examples. So question 1, we are to calculate the mass of copper that is formed when a current of 0.7 ampere is passed through a solution of copper 2 sulfate for 25 minutes. So in bracket we are given the RM of copper, which is 64, and we are told 1 Faraday is equal to 96,500 coulombs. So if you remember, the formula that we are supposed to look when we are calculating mass deposited is equal to Q multiplied by RM divided by N times F. So first of all, we have to get Q, and Q can be gotten by IT. I, we say, is current, and T, we say, is time. And remember, we said time must be in seconds. So the current here is 0.7 multiplied by time. The time is 25 minutes, but we have to convert it to seconds by multiplying 60. So we are going to have 0.7 times 1,500 seconds. What we are going to get here will be 1050 coulombs. That's the quantity of electricity passed. Then we come to this formula. We are saying mass will be equal to quantity, and quantity here we have gotten 1050, that is here, multiplied by RAM. The RM of copper is 64. It is given in the bracket. That's times 64 divided by N. N is the number of Faradays. In other words, the number of electrons lost or gained. Or we can say N is the value on the charge of the metal. So here the electrolyte is copper 2 sulfate. So it contains copper 2 ion and also sulfate ion. So copper 2 ion is written like this. So that means the number of Faradays is 2 here. Or the value on the charge of the metal, that's N again. So the number of electrons that will be gained here will be plus 2 electrons. So that means the N that we are going to use in this formula is 2. Then we are going to have 2 multiplied by F, and we say F is Faraday, and we say 1F is equal to 96,500 coulombs. So when we put all this in the calculator, we are going to get 0.348 gram. So that will be the mass of copper deposited or formed. Question number 2, we are told calculate the mass of chlorine liberated during the electrolysis of molten sodium chloride when a current of 2 amperes is passed for 4 minutes and 15 seconds. So in bracket, we are given the RM of chlorine, that's 35.5, and we are told 1 Faraday is equal to 96,500 coulombs. So we can do the same formula. We start with, first of all, getting Q. Q is given by IT, and we said where I is the current, and current is measured in ampere. So we're going to have 2 multiplied by time. Let's check the time. The time is 4 minutes and 15 seconds. Remember, we are told time must be in seconds. So we have to take this 4 multiplied by 60 so that we convert into seconds, then we add 15 seconds. So here we are going to get 2 amperes multiplied by 255 seconds, and we are going to get 510 coulombs as our quantity of electricity passed. So we are going to have the formula for mass deposited, which is equal to Q multiplied by relative molecular mass. Here we are dealing with chlorine. Chlorine exists as molecular form. So we are going to write the RMM divided by N times F. So we start. Mass deposited will be equal to 510, which is our quantity of electricity passed, multiplied by 71. Where is this 71 coming from? The 71 is coming from the RM of chlorine, which is 35.5, multiplied by 2, because chlorine molecule is composed of 2 chlorine atoms. So each is having 35.5 as it is RAM, then we multiply by 2 so that we get 71 as our RMM, relative molecular mass of chlorine, divided by N. So what is our N? That's the number of Faradays. First of all, we have to have chlorine, so chloride ion like that, because we're having molten sodium chloride. So these chloride ions will lose electrons to form chlorine gas. So the number of electrons that is going to lose will be 2, because we have to put 2 here to balance the equation. So the number of electron gain or loss is the number of Faradays. So we're going to put 2 here. Then multiplied by F, that's Faraday. And remember, Faraday is 96,500 coulombs. So when we put all this in the calculator, we are going to get 0.1876 gram. So that will be the mass of chlorine liberated. Question number 3. We are told what mass of copper remains from 2.0 gram at the anode if a solution of copper 2 sulfate is electrolyzed using a current of 1 ampere following through an electrolytic cell for 20 minutes. Then in bracket we are given the Rm of copper, which is 63.5, and we are told 1 Faraday is equal to 96,500 coulombs. So here we are going to start looking for the quantity of electricity passed, and quantity is gotten by IT. I is current, which is measured in amperes. T is time, which must be in seconds. So the ampere that we are given here is 1 ampere. So the current is 1 ampere multiplied by the time given here is 20 minutes. We take 20 minutes, multiply by 60 to convert it into seconds. When we put this one in the calculator, we are going to get 1,200 coulombs. So we write our formula. Mass will be equal to Q multiplied by Rm divided by N times F. So Q is what we have gotten now, 1,200, then multiplied by the Rm of copper, which is 63.5. It is given in the bracket, divided by N. Our N is 2 because we are having our electrolyte to be copper 2 sulfate. So the ion that we are having is copper 2 ion. So this 2 is the number of Faradays. So next, multiplied by F, we said F is Faraday, and we say 1 Faraday is equal to 96,500 coulombs. So we are going to multiply it by 96,500 coulombs. When we put all this in the calculator, we are going to get 0.3948 gram. So remember here we are told what mass of copper remains from 2.0 gram at the anode. So that means mass remaining will be equal to the original mass given minus mass deposited. That is the mass that we have gotten now in calculation. So 2.0, which is the original mass, minus the mass deposited, which is 0.3948, what we are going to get will be 1.6052 gram. So this will be the mass of copper remains from 2.0 gram at the anode. Question number 4. We are told in an experiment to electroplate iron with silver, a current of 0.5 amperes was passed through a solution of silver nitrate for an hour. Calculate the mass of silver that was deposited on iron. So in bracket we are given the relative atomic mass of silver, which is 108, and we are told 1 Faraday is equal to 96,500 coulombs. So we can just write the formula. Mass will be equal to Q times Rm divided by N times F. So Q is the quantity of electricity. How are we going to get it? By multiplying a current with the time. So the current given here is 0.5 amperes. So that's 0.5 multiplied by. So the time given is an hour. That's 1 hour. So 1 multiplied by 60 to convert into minutes. Then multiplied by another 60 to convert from minutes to seconds. That's the quantity. So what we have in the bracket is the Q. Multiplied by Rm, that is 108. That's the Rm of silver. 108 divided by N. That's the number of Faraday. So here we are told we are having silver. How do you write silver? We write Ag, then it's having a charge like that. Because we're having even the electrolyte to be silver nitrate. So we're going to have silver ion. So silver ion will gain 1 electron. So that means the number of Faraday is 1 multiplied by 96,500 Columbus, which is the Faraday. So remember you said 1 Faraday is equal to 96,500 Columbus. So when we put all this in the calculator, what we are going to get is 2.0145 gram. Next, we are going to go to extended questions. We're having question number 5, 6, 7. Kindly try to do it, and maybe you can give your answers in the comment section. I will be responding to you, inshallah. Thank you for watching.